Hello and welcome back. In this lesson, we're going to be going over zero and infinite slopes. So why don't we just start off by looking at this equation. Y is equal to 0x plus 3. Now we talked about what you would do if the slope was a positive number, if the slope was a negative number, if the slope was a fraction, but we did not talk about what you would do if the slope was 0. So why don't we just use the same method we normally would use? We see from the equation above that b is equal to 3, therefore the y-intercept is equal to 3, and a point on the line is 0, 3. So that is the y-intercept, because we know that on the y-axis, any point on the y-axis has an x value of 0, therefore x is 0, and y is 3. So we can plot that point on the graph, and that's the first step. Alright, so the next step is to look at the slope. In this case, the slope is 0, so we would write that down. And then, as I said before, if the slope is ever given to you in a whole number, it's very useful to rewrite that as a fraction, or as that number divided by 1. So we write 0 divided by 1. And we also know the slope is given by rise over run. So in this case, the rise is 0. So what does that mean, the rise is 0? We know that the rise tells us the amount by which y changes. If the rise was positive, that would mean that y was increasing. If the rise was negative, that would mean that the y value is decreasing. But the rise is 0. You're not rising at all. So that means that y doesn't change. It stays the same. And our graph would look like this. Okay, so we notice that there is never any change in the y value. It's always at the same y value, which is reflected by the fact that the rise is 0. And looking back at the equation, we had y is equal to 0x plus 3. If we multiply anything by 0, it just cancels out. So we could have written that as y is equal to 3. And when we compare y is equal to 3 to the graph, we know that that makes sense. Y is equal to 3 is telling us that y is always equal to 3. Looking at the graph, we see that that line, the y value of that line, is always equal to 3. And we could do this kind of approach with any kind of equation where we have y is equal to some number. If you were told that y is equal to 2, well then y is always equal to 2. So you would sketch it intersecting the y-axis at y is equal to 2. If y is equal to negative 3, well you would sketch it at you would sketch the line so that y is always equal to negative 3, and it would intersect the y-axis at negative 3. Okay, so in general, that is how you're going to approach that kind of question. If you're given y is equal to some number, you sketch a horizontal line that intersects the y-axis at that y value. Okay, so the other thing I wanted to go over. You'll notice in the title that we also have infinite slopes. We went over what would happen if you were given the equation y is equal to some number. But what if you were given the equation x is equal to some number? For example, x is equal to 3. Well, it's the exact same idea in a sense that this equation is telling us that x is always equal to 3. So our line would look like this. It doesn't care about the y value. If I chose y is equal to 2, I would end up getting x is equal to 3. If I chose y is equal to negative 4, I would still get x is equal to 3. That is because x is always equal to 3. Same thing if x was negative 4. I would draw it as a vertical line intersecting the x-axis at x is equal to negative 4. And so you'll notice in the title that we have infinite slopes. So why do these lines have infinite slopes? Well, because they are increasing infinitely quickly without any change in x. Yeah, so without even having any kind of change in x, y is already increasing all the way to the top forever and ever. So that's why we say that the slope is infinite. It is infinitely large. So once again, just as a review, if you're given y is equal to some number, for example y is equal to 2, you draw that as a horizontal line intersecting the y-axis at y is equal to 2. If you're given an equation like x is equal to 3, you draw that as a vertical line intersecting the x-axis at x is equal to 3. So that's all I wanted to go over for this lesson. In the next few lessons, we'll be going over solving linear equations and isolating variables, but for now, thanks for watching.